In 1969, they started their first experiment. They had to solve the problem of what nutrient is it in sewage that's causing these algal blooms? Is it carbon? Is it nitrogen? Is it phosphorus? So the first experiment they did in Lake 227, they added nitrogen and phosphorus to a low carbon lake. And it was very quickly after they added these nutrients, the lake turned to pea soup, putting to bed the theory that carbon is a nutrient that stimulates the growth of these nuisance algae. So they also had to solve the problem, well, if it's not carbon, then what is it? Is it phosphorus? Is it nitrogen? So they did another experiment, this time in Lake 226, which is the shape of an hourglass. They put a curtain across, added phosphorus, nitrogen, and carbon to one side, and only nitrogen and carbon to the other side. And as you can see in this now famous photograph, the side of the lake that received the phosphorus started to have these massive blooms of algae. These pioneering studies on eutrophiation on these algal blooms were published in the world-leading journals and were instrumental in convincing policymakers of the need to ban phosphorus from detergents, of the need to remove phosphorus from our sewage effluents. But these early studies on algal blooms done at ELA were just the beginning. Over 50 whole ecosystem experiments have been conducted at ELA over the last 4 decades on a broad range of environmental topics, issues that we're concerned about and want solutions to. I'm just going to provide a few very quick examples. Dr. Karen Kidd, she also had a dream. Her dream was to solve a scientific mystery as to why in some rivers scientists were starting to observe hermaphroditic fish. Now, some laboratory studies were pointing to synthetic hormones in birth control pills that women take and get flushed down the toilet and end up in our sewage and get released to rivers. But scientists had a very poor understanding of, well, how does this actually affect fish populations? So what Dr. Kidd and her colleagues did was they added very low, environmentally relevant levels of synthetic estrogen to an entire lake and monitored the fish populations. And what they found was astounding. With very quickly, the fathead minnow males start to develop female characteristics, such as the ovipositors you can see in the photograph. This prevented the fish from reproducing and caused the collapse of the fathead minnow population, almost led to the near extirpation of the local population. But there was good news in this study. When they stopped adding the EE to the lake, the chemical quickly disappeared and the fish populations rebounded. This study demonstrated of how effective it can be if we can remove estrogens from sewage, because those fish populations will respond positively and recover. Dr. John Rudd and Dr. Carol Pelly, two more ELA scientists, also had a dream. And their dream was to make fish safer for us to eat. Now, mercury is a trace contaminant in coal and other fossil fuels. When we burn that coal, it goes to the atmosphere, circles the world, comes down in rains on our lakes, accumulates in invertebrates and in fish. And high levels of mercury in fish are a human health concern because it is a central nervous system toxin, as we learned in sad stories like that in Minnesota and that in Grassy Narrows. So governments wanted industries to scrub that mercury from their smokestacks. The industry turned around and said, well, there's no evidence that the mercury coming out of smokestacks is linked with the mercury in fish. So what Dr. Rudd and Dr. Kelly did is they added a very small amount of mercury to a lake and its watershed using very special natural isotopes of mercury so they could track the experimentally added mercury. And what they discovered was that the added mercury quickly was converted to the toxic methylmercury formed by microbes in the bottom of the lake. This was taken up by organisms at the base of the food web and accumulated to high levels in fish. This was the very first study that linked the mercury that's coming down from the atmosphere with the toxic methylmercury that's found in fish. Their study led the United States government to put in strict regulations on mercury emissions from smokestacks.